All right, here's day number 2. We're going to work the second fundamental theorem again, this time with some free response style questions that I have created. All right, we're going to, at the local animal shelter, we have cat food being distributed into bowls each day during the month of April. You can see that the amount of food, F of t, F for food, T for time, is equal to that equation, that formula, if you will. F is measured in pounds, T is in days. Find the average rate of change of F of t during April. Indicate your units of measure. Well, based on my knowledge of exponentials, I can see that the people that are working the animal shelter need to step it up a bit, because each day you're only coming back with 92.5% of the food that you had the day before. So these cats are out eating the staff, and eventually someone's going to have to come in and dump a whole bunch in. Okay, so my guess is that the average rate of change of the food is going to be negative. Just a gut feeling. Let's see what we have. Now, I realize that rate of change normally means take a derivative, but the word average normally means stay away from derivatives, and that's the case here. The average rate of change during the month of April is simply going to be f of 30 minus f of 0 over 30 minus 0, since April has 30 days. Okay, plugging a 30 into this equation gives us that figure. F of 0 would simply be 5.934. And of course, 30 minus 0 is simply 30. My hunch was right. This will come out to a negative number, and it's going to come out to negative 0.1787. And again, if this is College Board, they will take it to 3 places, so either negative 0.178 or negative 0.179 pounds per day. Or you can say the food is decreasing by 0.178 or 0.179. If you use decreasing, you don't need the negative. And that's it for part A. Okay, part B says find the value of f prime of 15. Using correct units, interpret its meaning in the context of the problem, so we have to explain in terms of cat food and days of the month. All right, well, that's easy enough because we have the equation for f. It's right here. We just simply need to take the derivative and plug a 15 in. And this will always be a calculator style problem. So let's go ahead and I will type in f of t to the graphing calculator. I'll show you how to do the derivative if you don't remember or you don't already know how to. It's really slick using the graphing calculator. So here it is. All right, I've got it typed in as y1. That's wise to do on a free response style question because you're going to probably use this equation all 4 parts, at least 3 out of 4. So to type it in once is a time saver. All right, it's saved under y1. Let me get out of here. And on the main screen, I'm going to go math, but this time I'll go math 8, n derivative. It's the derivative with respect to x of, and I don't want to retype that again. Remember, it's stored under y1, so we hit vars for variables. Over to y variables. Function's already lit up, certainly not parametric or polar. Choose y1, and it just retyped it for me. It's going to take the derivative of y1, which is what I want, and then evaluate it when x is 15. So boom, there's your answer. And that is the correct answer. College Board, if this was theirs, they would accept negative 0.143 or negative 0.144. You can either round it off or truncate it. Okay, so that's part of it. And then it also says using correct units, interpret the meaning of this. Well, f prime of 15, remember f is measured in pounds, so f prime is going to be pounds per day. And the rate at which the cat food in the bowls was changing is decreasing, as I mentioned, by 0.143 or 0.144 pounds per day on April 15th. We do have to say that because each day that rate will change on us. All right, let me write that out. All right, there's my answer. On April 15th, which is tax day, also my dad's birthday, shout out to Dad there, the food in the cat's bowls is decreasing at a rate of 0.144 pounds per day. So Somebody's got to get in there and fill these things up. Or we're going to have a situation. The cats will let you know, trust me. I have 3 of them. All right, on to part C. Find the time when the amount of cat food in the bowls is equal to the average amount of cat food in the bowls during 30 days of April. I would imagine this is probably somewhere mid-month. So let's find out where and when. Of course, the average value formula is being called into question here. The average amount of cat food, that's going to be 1 over b minus a, which in this case is 1 over 30 minus 0, because there are 30 days in April. And we're going to integrate from 0 to 30 of the formula that we've been given, f of t. F of t is amount of cat food. So when we integrate it, that's the average amount of cat food. And we want to set that equal to the actual amount of cat food, which is, given by the formula here. So that's going to go on the other side. Now, as you can probably tell, there's no way to solve this algebraically, but I will get this left-hand side figured out on the calculator, and then I'll set it equal to the right-hand side. We'll graph the 2 equations and just see where they cross each other. Okay, working this out, we have 1/30th in front. The integral, remember this is still on the screen. That's still y1, so we can integrate from 0 to 30 very easily. Let's go. Just make sure it's there. Yeah, it's still there. Okay, so let's go math 9. And that's function integrator. Function integration, we're going to go from 0 to 30. Type in y1 using vars, variables. After a while you get fast at this, which is the whole idea. 68.774. Okay, that's good to know. We will use that. I'll try to keep it super accurate. Okay, we'll divide that by 30, of course, because we get the 1/30th out front. That should come right around 2 point something, maybe 2.2, 2.3. Let's try it out. Okay, divided by 30. All right, 2.292, that looks great. Let me type that in as equation number 2. And we'll just see where those 2 guys cross each other. It should be mid-month, so let's change the window. X is the number of days in April. Let's go from 0 to 30, I should say. And the Y's, who knows? I'll leave it how it is for now. Let's see. Yeah, that works just fine. Okay. Looks like it's going to be a little bit before the 15th. Second calc intersect, number 5. First curve, yeah, it's already pretty close. Second curve. Do you want me to guess? Yep. 12.199 days. That's going to be our answer. 12.199. All right, that's part C. We've got one more, and we'll be all done with this. Part D, number 5, my only example of the day. Says starting on May 1st, so the next month, the amount of cat food in the bowls becomes linear instead of this funky exponential function. And it remains linear. What's the first time in May when the amount of cat food in the bowls drops below a quarter pound? Now, obviously, you want to show the work. Okay, wow. Well, first things first, we need to get the equation of the tangent line. And so to do that, we realize that 30 days in is the end of April. Let's see how much food is left there. So if time is 30, the amount of food we're going to have to see. We already have it graphed, so again, let's go back to the graph. This time we can go to the table. And we just go to 30. Actually, that's not too far from where we were before. And it's 0.5723. If you need to be more accurate, you can hover over it, and then down on the bottom, you get a super accurate decimal. So I don't have to go out quite that far, but that's fine. Let me write that down on the other page. 0.572268. All right, that's more accurate than I could possibly need. Now let's find the derivative there as well. Let's go f prime of 30 and see what that is. Again, this cat food amount has been dropping, so my thought is it's probably going to be negative. The calculator will help us here. We already have it graphed. Let's get rid of the silly second red graph. We don't want that in the way. Okay. Okay, here's the graph. Second calc. This is kind of cool. Number 6, a lot of people don't realize you can use this. The derivative's right on here. If you go down to 6, and just go x equals 30, and you can see the slope is on there. In fact, I could have gotten the 0.5722681 that way as well. Could have saved this step. But the slope, or the rate at which cat food is decreasing, is negative 0.044615. So I'll write that down as well. All right, so we need to write the equation of the tangent line. And our tan line, I'll put in point slope form. It's going to be y minus y1, which is the 0.5 and change, equals the slope. And then, of course, the x, or t in this case, is 30 days. All right, that'll be the tan line starting on April 30th. And we want to see how long it'll take until y is less than a quarter pound. All right, I'll save you some of the agony of the details. You're going to have y equals negative 0.044615 t, and negative times negative is going to be positive, and you're also going to add a 0.572268 to the right-hand side. That's going to be 1.910715. All right, we want y to be a quarter pound. That's going to be 0.25. So we'll just put that in instead. We need to figure out what t is at that point. So we can subtract the 1.91 figure from both sides, divide both sides by negative 0.044615, and that's going to give us approximately 37.2. So after 37 days, early morning on the 38th day, the bowls will be down to below a quarter pound, or we're going to have to refill it. It does say, what is the first time in May? To me, the way I read that, they're looking for a date. And so it's going to be on the 38th day. And 38 days after April 1st is May 8th, which happens to be my mom's birthday. How about that? Worked out pretty well. I'd love to say I did that on purpose, but that was just total coincidence on both cases. And there we go. That's it for number 5. And that's it for section 4F. Great job, everybody. See you next time.